Okay, another exciting day of optimizing functions. Go ahead and read that problem if you haven't already. This one, we have a problem because we don't have an equation or a formula. So we have to come up with one all on our own, and we can do that by analyzing patterns. All right, so let's say n equals 0. The first case, we have 80 people, and we're charging $200. Which is basically, if you saw somewhere with a rent of $200 at this point in your life, it'll probably be your parents' house or a cardboard box. Rent is much more expensive, and you'll find that out next year at college. All right, so n equals 1. Let's say we have, we're trying to increase the pay now. So 200 plus 20, and well, that's one less person. All right. So actually, maybe I should write it as, maybe this will help us see the pattern faster. 79 minus 1. All right, the next case, we're going to, 80 minus 1. Okay. So then the next one, it would be 80 minus 2, or 78. And then 20, or 200 plus 2 times 20. All right, the next one, it'll be 80 minus 3, or 77. And then $200 plus 3 times 20, okay, which will be 60. So it looks like for any n value, the equation is going to be 80 minus n times 200 plus n, 20n, or n times 20. All right, so that's our equation now. The rent for a certain number, 80 minus n times 200 plus 20n. Okay, so if we want to optimize this first, I'm going to multiply it out. You don't have to. You could use the product rule. I just think it's easier to multiply it out. All right, so that'll be plus, what's that? If I have this right, I think it's 1400n minus 20n squared. Okay, in order to optimize this, I have to take the derivative. So 1400 minus 40n. All right, so 1400 equals 40n. And divide by 40, I think it's 35. So that's the number of people I should have in order to optimize or maximize my revenue. And so find the rent to charge. So that's going to be 200 plus 35 times 20. All right, so 200 plus 700, $900. That's how much I should charge to get the maximum amount of revenue. And today, if you find an apartment for $900, that's pretty good. All right. You might be in a dangerous neighborhood, but at least you'll have a cheap house, right? All right, now the most fun that we could possibly have, 3D shapes. My drawing comes in here. It's great. Find the largest cone that can be inscribed inside a sphere of radius 5. Here's my beautiful sphere. Let's try to get kind of fancy here with this cone. Okay, see that curved line? That makes it fancy. All right, there we go. We have a cone inside of a sphere. How exciting. All right, so we're trying to find volume of the largest cone that can be inscribed in this sphere. So hopefully you remember volume is 1/3 pi r squared h. All right, but right there I have two variables, and I'm not going to want that many variables. So we're going to have to find some more information. So from here to here, that'll be our radius in our sphere, 5. Okay, and so would this. This would also be 5. So if I'm trying to figure out what that's going to be. All right, and this is my radius of my cone here. And let's just call this y, or x, I guess. It doesn't matter. H. I don't know. I'll call it y for now. Why not? So we have this picture going on. Okay, so from my total height at this point is y plus 5. That's still not going to help me because then I just change r. I have r and h. Still too many variables. All right, so now we can come up with another equation using this right triangle here. We have r squared plus y squared equals 5 squared. Solving this for r squared, that'll be 25 minus y squared. All right, and I could solve this for r, but I recognize that I have r squared in my equation, so I'm just going to leave it like that for now. Okay, so and then last step, let's see. Oh, I have everything in terms of y now, so I could just go ahead and plug it in. So I have 1/3 times r squared, which is 25 minus y squared, times h, which is y plus 5. So I'm going to multiply that out. You could do the derivative right from here. All right, I just think it's easier if I multiply it out. 25y plus 125 minus y cubed minus 5y squared. It's not in order, no big deal. All right. So now I can take the derivative from this. Okay, bring my constant down. So I'm going to end up with 25, and I'm going to try to keep it in order here, minus 10y minus 3y squared. So I'll set that equal to 0. Oh, this one's a good one because it factors. 5 plus y, 5 minus 3y, I believe. Check it. So 25 minus 15. Yep, that'll work. Okay, we're setting that equal to 0. So y can be negative 5, or y can be 5/3. And we can't have a length of negative 5, so it's got to be 5/3. All right, and we're trying to find the volume of the largest cone. All right, so I'm going to take this y value now and plug it in. So my height, my total height, is going to be 5/3 plus 5, which is the same as, what, 15/3 plus 5, so 20/3. 20/3, there we go. That's my height. My radius, 25 minus, that's 5/3 squared. 25 minus 25 over 9. If you really want to put that as a fraction, it'll end up being 200 over 9. Good enough. All right. Let's find the volume now. 1/3 pi times r squared times h. There you go. Maximum volume, and that would be units cubed. And if you want a decimal, I believe if I typed it in right, it'll be about that. Okay, but you can leave it as exact. See, that was a fun problem, not too crazy. All right, let's keep going. All right, perfect. Windows. Everybody loves to build windows, right? We have this round part here, and then we have a rectangular part. And we're trying to, we have 12 meters of framing. That's probably going to be exciting. And what is the width that lets in the most light? So we're talking maximize our area. All right, so our constraint, what's going to limit us? That 12 meters. All right, so that's going to be the perimeter. So let me get some units on here. I'm going to call this part R. So that makes the bottom part 2R. Okay, this part I'll call H for height. I could use width, I guess, and height, but R's fine. I like that better. So to find the perimeter, I'm going to have 2h plus 2r, that's for the bottom, plus now the rounded part. Normally it's pi times 2r, or pi times diameter, but we're dividing that in half. So that's just pi times r. And our constraint has to be equal to 12. Now we're trying to maximize our area. Okay, so we have 2RH for the bottom plus 1/2 pi r squared for the top. So let's go ahead and solve for one of the variables. I pick h because why not? I have two r's, maybe that'll be harder, I don't know. So I'm going to get anything without an h over here. Minus, that's pi r. And divide everything by 2, so I get 6 minus r minus 1/2 pi r equals h. Plug it into my function. Okay, I'm going to choose to simplify before I move on. So we'll get 12r minus pi r squared minus 2r squared plus 1/2 pi r squared. All right, and from here I'm just going to take the derivative. So I get 12 minus 2 pi r minus 4r plus pi r. So I have minus 2 pi r plus pi r. 12. So that gives me minus pi r minus 4r. We're going to set that equal to 0. So if I factor out an r, I'll come up here. I get pi plus 4. So the radius is 12 over pi plus 4. All right, so then for our actual width, to answer the question, what's the maximum width? It's 2 times that. And it's perfectly fine to write that, and that would be, in this case, meters. All right, but I'm just making sure I did this right. Okay, yeah, so then the only other thing that I could do is put this equals the width. Okay, perfect. So we have one more problem to get through. Now, this is a good problem here. Find an equation for the tangent line having a maximum slope. So we're trying to maximize the slope of f of x. So what we're secretly doing is maximizing f prime of x. All right, so f prime of x, we need to find that first. Negative 2 minus 2x minus x squared. And we're maximizing that. So take the derivative. Negative 2 minus 2x. Where's that 0? Looks like negative 1. All right, and to justify that, this is a good way of doing it. Since this is a linear function, the derivative of that is just going to be negative 2, which is always, so it's always less than 0, okay, for all x. So it's all f is concave down like a frown. All right, so negative 1, x equals negative 1 is a max. There we go. All right, so now find an equation, blah, 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 of the tangent line having maximum slope. So now we have to find the equation of the tangent line, last step here. I'll pick purple, why not? So remember, for the equation, we need a slope. This is our x value. Find the slope. Plug it in. I think you get negative 1. And we need a point, so plug that into f. So that's what? 2/3 plus 2 minus 1 plus 1/3. So we get 2. So our equation is y minus 2 equals negative 1 times x plus 1, or You know, you could write it as y equals 2 minus x plus 1, or you could multiply it out, 2 minus x minus 1, negative x plus 1, whatever you want. Any of these would be great. All right, guys, so work on some problems. Have a great day.